The operation of a microwave seems incredibly simple. You stick in a plate of food, and when you take it out, it's magically heated and ready to be eaten. But what happens on the inside turns out to be a lot more complicated than just this. As you can see, the temperature of the rice from the fridge is around 47 degrees Fahrenheit. After it is heated in the microwave for 1 minute, it rises to a temperature of 150 degrees Fahrenheit. The temperature of rice doesn't just raise by 100 degrees Fahrenheit out of nowhere, so what exactly is going on? In a video from the Edison Tech Center, Rudy Dane, an engineer who helped develop the microwave oven technology, explains that the heart of the microwave is the magnetron. The magnetron is a high-powered vacuum tube located on the side of the microwave and is responsible for producing the microwaves from electricity. Although he delves into some pretty complicated physics concepts, the general operations of a microwave begins with the electricity heating up a filament in the center of the magnetron. Similar to an electrolytic cell, this filament serves as a negatively charged cathode, while a circular piece around the filament serves as the anode. Through a process called thermal ionic emission, he excites the electrons and causes them to become emitted from the metal filament into the vacuum. While we would expect the emitted electron to travel radially outward, a magnet under the anode creates a magnetic field which exerts a perpendicular force on these electrons. This causes the electrons to move in a circular fashion as opposed to a linear fashion. The anode has these small cutouts called resonant cavities. These resonant cavities have a positive end and a negative end. As electrons travel past these cavity ends, they are creating an electric field, which produces electromagnetic energy in these cavities. This energy causes the cavities to resonate at just the right frequency to produce microwaves. This process is also used to generate microwaves in satellites. Microwaves are used in communications between satellites in space and devices on Earth because the wavelengths are short enough to penetrate Earth's atmosphere. Okay, so how then do these generated microwaves heat up food? These microwaves are guided to the microwave chamber where the food is by a waveguide, and these waves will bounce off the metal walls of the microwave oven until it penetrates the food. As explained by an article from Nature, the microwaves create an electromagnetic field around the food. Because the waves are moving and the food is rotating inside the microwave oven, polar water molecules are constantly shifting their orientation to align their positive and negative ends in accordance with the electromagnetic field. The kinetic energy produced from these movements or vibrations are what produce the heat within the food. The rest of the food is heated up through conduction as the kinetic energy of these water molecules is transferred to the other molecules in the food. So what exactly is the difference between microwave cooking and stovetop cooking? Gas stovetop cooking is cooking through conduction. Fire excites the molecules in the pan, which subsequently excites the molecules in the food and cooks the food. This is cooking from the outside in. As you can see from this piece of meat cooked on a stove, the outside is brown, but the inside is still raw. On the other hand, since microwave ovens use microwaves to cause the water molecules in the food to vibrate, this is cooking by radiation. As you can see from this piece of meat cooked by the microwave, the browning of the meat is uneven because the distribution of water within the meat is uneven. So which type of cooking is better? Is microwave food somehow bad for you? Well, according to studies conducted by the Harvard Medical School, there's no evidence to these claims that microwaves zap nutrients out of food. Vitamins break down at high temperatures, and because microwave food gets hot extremely quickly, this microwave food can lose its nutrients more easily. But the same thing can happen if you overcook food on the stove. However, we pretend to prefer stove-cooked food because it cooks food more evenly, tends not to dry out the food as quickly, and conducts the Maillard reaction more easily, which gives cooked food its flavor. But for now, if you're in a hurry, there's no reason not to microwave your food.